So, in this final module of the lecture, I just wanted to talk to you briefly about the concept of AI ethics. And I am not an expert on this by any means. It is an emerging field. People really have only started to do kind of their PhD dissertations in this over the last 5 or so years, but it's important to be aware of whether you're just going to be an engineer using AI or if you're going to go to grad school and it's something that you want to dive into in more detail. So you're going to be, as part of your discussion board, reading about the resignation of Geoffrey Hinton. He was one of the big developers of deep neural networks, actually before we had the capability to actually implement them and see that they worked. So his kind of mathematical theory of their existence predated our access to adequate training data to really take full advantage of them, along with hardware to actually train them and actual algorithms to make it feasible. So he kind of was ahead of his time. That's why he's often called the godfather of AI. But he had been working, in addition to his academic appointment at the Vector Institute at the University of Toronto, had been working for Google for quite a while, and he quit this past weekend. So I can never reuse this video, or people will be like, "Oh, I googled it. It was actually a year ago." But anyways, a lot of his concerns were based upon uncertainty of how AI would be used in the future, and part of that uncertainty relates to the fact that we really don't have like kind of a universal ground truth or laws or ethics that are agreed upon about how AI needs to behave. So remember that what we're talking about with AI is trying to train computers to be and do things that humans can do. So we know that it's very important in our lives to have some basic fundamental assumptions that humans are going to behave in a certain ethical way. So how do we do that for AI, and how can we do it outside of the legal system? Not saying that we don't want legal protections in place as well. But of course, there are issues there with jurisdiction. If we regulate in a particular way, what's going in the United States, what would stop individuals in another country from necessarily not following those rules? That's one of the things that I don't know if the article that I linked for you all for Geoffrey Hinton's resignation brings that up, but that is one thing that I saw that he brought up in his particular interviews of concerns. But just know that people are thinking about it. They've been thinking about it really for the last 5 years, and it's kind of in addition to the legal system, just trying to have a framework in place to ensure that we have some expectations of what how ethical AI models should be. And this is really important because even though you think of AI as it certainly is getting more notoriety now as it's becoming more popular, particularly like rudimentary applications of supervised learning, like recommendation systems, the way that Netflix, you think about it, when you give the thumbs up, thumbs down, or thumbs in the middle, you're providing labels. And there's been, it's a well documented algorithm that you can look into, the way that it actually makes recommendations for additional shows or series that you may want to watch, depending upon your prior viewing habits, is actually a supervised learning AI model. So AI has been used quite a bit in kind of subsets of industries. And one thing that we found is, not surprisingly, it has some results that aren't very good from an ethical point of view. So here is some research. Adair Morse out of Berkeley noted that these online lenders that are kind of qualifying or measuring or assessing risk of borrowers based upon factors that are entered, they tend to charge higher interest rates to individuals of color versus white or other individuals. So obviously, there's a huge financial ramification to that. In addition, search engines, if you go to Google and you search the term CEO, you would see it's known that you would see more images of white men than you would of individuals of other races or other genders. And there's many examples like this. And to some extent, and we'll talk about the reasons that the AI acts like this, you could argue that it's not surprising because remember that supervised learning, particularly these more classical examples of AI, they are trying to learn patterns in data. So if you have a particular data set that exhibits some sort of bias, it wouldn't be surprising that the model that you train on that data set would exhibit that same sort of bias. So even if you have what you could say, well, historically, it's just representative that more white men are CEOs than non-white men. That is true from a data point of view, but do you necessarily, from an ethical and society point of view, do we want something like a search algorithm to necessarily 100% just accurately reflect historical data, particularly if we're concerned about providing pathways for economic mobility for historically marginalized individuals? So just important things to think about from an ethical and AI framework. I always get this is like way too much detail, but one of the things when I get in arguments with people, sometimes they'll say, well, you say, oh, well, that's just the facts or that's just the data, and that's not all the things that we don't always need to just be concerned about necessarily reflecting data in our human interactions. So there's lots of points at which bias can be introduced throughout the ML process. So we actually showed this machine learning workflow during the first lecture, how you go from data collection to data preparation, model selection, training, validation, and actual inference or making predictions at step 6. And you see a lot of people are working on this now, and they've identified a lot of different points at which you can introduce bias into your machine learning model that might introduce some sort of ethical concerns. So just know, like here, representation bias, I'll just read the definition formally, occurs when the sample underrepresents a part of the population and therefore fails to generalize well for that subset of the population. An example that I always give here is, say you're building some sort of computer vision solution, or maybe it's not even actual based on images, but it's some sort of, I think we've all used, I used to use this analogy physically at SAC, and then I would always forget that SAC doesn't have automatic paper towel dispensers. But say those automatic paper towel dispensers, right? You pass your hand underneath, and based upon optical reflection, it determines whether someone is there and whether you should actually dispense paper towels. Obviously, just the underlying physics, if skin tones are different, the level of reflection will be different from that particular sensor. So if you were to do that and implement it through AI, and you were to train it only on individuals from a particular skin tone, it's just natural to assume that it will work well for individuals that don't have that skin tone. That's just physics, and that's just data. So as we're kind of designing an AI system like that, we need to be cognizant of the fact that we can't have representation bias within our actual training data. And there's an example there for pregnant women, I believe. Yeah, so just something to read and something to reflect on. So there are lots of different pieces of the AI ethics puzzle. Since we're moving to the end of the semester, and I want to be quick here and respectful of your time, I won't read them, but if you're interested in reading them in detail, really, really cool stuff to reflect on and important stuff to reflect on. A term that you should know is this idea of responsible AI. It's a big, big buzzword, and rightfully so, in the research community right now. And one of the things that I wanted to point to is this idea of interpretability for human compatible AI. If you think back to those neural networks, I said that basically the way they works is they were just basically a function approximators. And what was happening is during training, you were learning the weight and bias values in order to fit whatever training data that you were working with. And in that case, right, if you're doing something like classifying cats and dogs, oftentimes there are techniques like saliency maps and whatnot that you can point to parts of the network that are actually most responsible for the decision making. And you can probably, even if you're not an AI person, think about the ways that you would do those sorts of experiments. But generally speaking, AI models tend to act in a kind of black box type fashion, in the sense that, I mean that in the aircraft sense, like you don't know what is going on the inside. So one of the ways that we can ensure that AI is responsible and behaves in an ethical fashion is develop models that are more explainable, where we can actually point to, hey, after we've trained this, the reason that it behaves in this way is this particular portion of the network. So just some terms to keep in mind and things to think about, especially in light of this weekend's activities. When I went to put the module up this morning, I said, hey, I really need to talk about the general introduction to AI, because, very, very likely, if you're taking a programming class, you're interested in AI, and just with everything that happened this weekend, I think it's always important whenever, especially in the first 2 years of an engineering degree, when you can start to think about things that are relevant in the market right now. That's really, really good, because oftentimes you just get bogged down with basic physics and mechanics and Newton's laws and Maxwell's equations and so on. Not a lot of relevance, but hopefully you found this lecture enjoyable, and I will see you all soon.